Have you ever wondered how you could possibly teach a computer, a machine that only thinks in ones and zeros, about something as messy and, well, human as emotion? Today, we're going to do just that. We're going to build a mathematical bridge that connects our feelings directly to machine code. And this, right here, is the heart of the problem. You see, our emotions aren't these logical things we figure out. They're primal, they're chemical. They are basically the brain's fire alarm, and it goes off way before the rational part of our brain even has a chance to figure out if there's a real fire. So, how do you translate that alarm into something a computer can actually understand? This really shows you the massive divide, what we're going to call the feeling gap. On one side, you have the analog, chemical soup of human biology. It's complex, it's nuanced, it's subjective. And on the other side, the clean, perfect digital logic of machine code. It's precise, it's objective, it's binary. The question is, how on earth do we build a bridge across that gap?
To build this bridge, we've got a roadmap. It's a clear 6-step plan. First, we'll really get to grips with that feeling gap. Then, we'll figure out how to map the emotional rainbow, give those feelings some GPS coordinates, and then dive into the actual mathematics of the heart. After that, we'll see how an AI gets its own emotional dictionary. And finally, we'll connect the dots all the way from brain chemistry to code.
Okay, so let's start at the very beginning. Why do we even need this bridge in the first place? Well, our feelings aren't just abstract ideas. They are real physical events happening in our bodies. When your brain senses something, say a threat, it doesn't sit down and think about it. It just reacts. That's that fire alarm going off, that instant state of emergency triggered by a flood of chemicals. And here they are, the actual chemical messengers that trigger that alarm. You've got hormones like adrenaline and cortisol, which create stress and get you ready for fight or flight. And then you have others, like dopamine and oxytocin, that send messages of reward, pleasure, and connection. This right here, this is the raw biological language of how we feel. All right, so now for the first real step in building our bridge. We need to create a map of this incredibly complex emotional world. Just putting labels on things like happy or sad, that's not going to cut it. It doesn't capture the nuance. We need a much better system. So this brings us to two very different ways of mapping emotions. The first is the categorical model. Think of it like a box of colored pencils. Each feeling is its own distinct, separate color. You've got red for anger, blue for sad. Simple. But then there's the dimensional model, which is much more like a continuous rainbow. It gets that emotions blend together, that you can feel a kind of reddish-orange, a mix of excitement and anxiety. And for a machine, that rainbow is a much more powerful and accurate map. So now that we have our beautiful rainbow map, we need to add a grid system. Because if we want a computer to be able to read this map, every single possible shade of feeling needs its own unique address. It needs its own specific GPS coordinates. Okay, let's go through this slowly. Our first coordinate, our first axis, is called valence. Just think of this as the horizontal east to west line on our map. All it does is measure how pleasant or unpleasant an emotion feels. So way over on the right, you have really positive feelings, like joy. And way over on the left, you have negative feelings, like fear. Simple as that. Our second coordinate is arousal. This forms our vertical north to south axis. Now this one doesn't measure good or bad. It measures energy. It's all about the intensity of the feeling. Down at the very bottom, you have calm, low energy states, like feeling serene. But as you move up that axis, the energy cranks up to these highly activated states, like excitement, or even all the way up to panic. Now, there is technically a third dimension called dominance. It measures how in control or submissive a feeling makes you. But to keep things simple, and honestly, because it's a lot harder to measure from just text, most models you'll see just stick to that 2D map of valence and arousal. So let's actually plot a feeling on this map. Let's take joy. Well, it's a very pleasant feeling, right? So it gets a high positive score on the valence axis. And it's also a very high energy feeling, which means it gets a high score for arousal. And boom, that puts it squarely in the top right quadrant. Just like that, the feeling of joy now has a specific mathematical address. Now let's try the opposite with sadness. It's an unpleasant feeling, so that means it gets a negative valence score. And it's usually a pretty low energy state, so it gets a low arousal score. And as you can see, it lands all the way down in the bottom left quadrant, basically the mathematical opposite of joy. And now, we have reached the absolute keystone of our bridge.
This is the moment, the critical step where we translate our emotional map into the only language a computer really gets, the universal language of mathematics.
So this is the big conceptual leap, right? How do we take that dot on our map, that location for joy, and turn it into something a machine can actually run calculations on?
The answer is we represent emotions as vectors. Now, a vector is just a fancy word for the numerical GPS coordinate of that feeling. So joy might be represented by a pair of numbers, something like 0.8 valence, 0.7 arousal. And just like that, a subjective human feeling becomes objective, computable data. And once feelings become vectors, we can do something really powerful. We can use math to measure the distance between them. For example, the mathematical distance between the vector for anger and the vector for disgust is just 0.29. That tiny number is objective proof of what we already feel, that these two emotions are very, very closely related. But by contrast, look at the distance between the vectors for anger and joy. It's 1.34. A much, much bigger number, which mathematically confirms that these two feelings live very far apart on our emotional map. This is the magic of the bridge, turning subjective feelings into objective, comparable numbers. So with our mathematical bridge fully constructed, we can finally see what kinds of things travel across it. And the most common application by far is automated sentiment analysis, which is where an AI is taught to read and score human emotion in text. Now, a lot of people think this whole thing is just a simple game of counting. You find 2 positive words and 1 negative word in a review, so the review is slightly positive. But the reality is so much more sophisticated than that. The reality is that modern tools use these advanced emotional dictionaries, or lexicons, like this one called VADER. And in here, words aren't just a simple +1 or -1. As you can see, they have these really precise scores. Attractive is a strong positive 1.9, while avoider is a negative 1.8. But it's even smarter than that. VADER understands that the word amazing, written in all caps with 3 exclamation points, is way more intense than just amazing. It weighs all of it, grammar, punctuation, even emojis, to generate a truly nuanced emotional score for any piece of text. So let's just zoom all the way out and look at the incredible journey we've just taken. We have successfully built our bridge. We have translated the raw, biological experience of a feeling into the clean, logical language of computer code. This single slide really captures the whole thing. We started with the actual chemistry happening in our brains. We learned how to plot those feelings on a dimensional map. We then translated those coordinates into mathematical vectors. And with that, we built the foundation for an AI that can actually analyze and understand human sentiment. We have officially crossed the bridge. So we've built this bridge, this sort of Rosetta Stone that allows machines to read our inner worlds. But as this technology forces us to put numbers on our feelings, it also forces us to look in the mirror. So I'm going to leave you with this question. As machines get better and better at reading our emotions, what is it that we must learn about ourselves?